Okay. Again, without a calculator, you gotta almost think of it as money, especially with the decimal. Fractions are different, but you gotta know the rules for fractions. Because what's coming is not just adding fractions, but sticking variables on it. So if we can't do this with just numbers, we're not gonna be able to do it when there's a variable attached. First thing, the common mistake I saw with that one, and it didn't happen a lot. The Pearson quizzes were pretty good, especially when you took advantage of the second attempt if you needed it. Some put the positive. Look at it, negative, and then minus a number, and you put positive. I don't know if it was because you saw two negatives, so you thought it was a positive, or you just didn't think about putting the negative as part of the answer. So that's where you have to be careful about how you answer the question. Your test for chapter 0 is on Pearson. So if you make that mistake by not putting the negative on a question like this, when the answer is negative, it's going to mark it wrong. And there's no partial credit because you're not turning work in with it. So, do it on paper for your own good, and then type it in. Okay, I highly recommend you do it on paper and then type it in. Am I going to be able to hold you to that? No, I'm not going to be at home looking over your shoulder. At your home looking over your shoulder. What I'm going to do is I'm going to set up the test where it will be available either Monday after class and you have until Tuesday night, or depends on how long it takes us to get through the rest of chapter 0. It will start Wednesday after class and do Thursday. That's why I left the times where they're blank. That it'll be next week. Okay. So, negative 38.9 minus 21.4, you spend $38.90. You spend another $21.40. So basically you'll spend, so that's a negative. You're subtracting it from your bank account. So that means right away, your answer is negative. So you've written that down and you basically are combining 38.9 and 21.4 to see how much negative we have. So that's a 13 carry the 1. 1 plus 8 is 9. 9 plus 1, that's a 10. There's my decimal. Carry the 1. 1 plus 3 is 4. 1 plus 2. So 60.3. So it's a negative 60.3. But I took care of the negative right away. Okay. Common denominator when we add or subtract fractions. So this is a negative 3/11 plus positive 7/9. It's addition. So we need a common denominator. So what's the first number? What's the least common multiple that 9 and 11 will go into? 99. So we have to change these fractions into, still addition, into 99. Don't forget this first fraction is a negative. That's something that gets left out. Because when you're rewriting the new fraction, this is now a negative still. That's addition. To change this fraction into the 99, you have to multiply the denominator by 9 to change 11 to 99. So you got to multiply the numerator by 9. So our new numerator, 9 times negative 3, is a negative 27. And to convert this fraction, 9 into a 99, you're going to have to multiply its denominator by an 11. So that means you got to multiply that numerator by 11. 11 over 11, you're just multiplying by 1. 7 times 11, that's a 77. If you were doing this in class as an in-class test, you don't have to do this step, but here's what's happening. When you have the same denominator, you add or subtract the numerators. Negative 27 plus 77 all over a single 99. And then a negative 27, and you add 77 to it. So you spend $77, and then you deposit 77. Or basically, negative 27 plus 77 is the exact same thing as 77 minus 27. I have a negative 27. I still have negative 27. That's positive 77. That's a positive 77. So the same thing is subtracting. Or sometimes you say it like this. I have 27 negatives. I have 77 positives. Who's going to win, the negatives or the positives? Which one has more? Negatives or positives? The positives do. How many more positives do they have? It's 50. There's 50 more positives than there are negatives. So the answer is a positive 50 over still a 99. Then you got to reduce it if it can. Well, the only thing going into 99 is 9 and 11. Neither 9 or 11 are going into 50, so it's not going to reduce. If it can be reduced, you got to reduce it. On number 3, the very first thing, it's a negative divided by positive. Very first thing, I would make sure I don't want to forget it. The answer is going to be negative. Because when I see students do work right here, the next step, they forget to put the negative. They just leave it off. So the very first thing you should do is remember the answer is going to be a negative, just in case. When we divide a fraction, we change this to multiply by the reciprocal. So the first fraction does not change. It stays negative 5 over 3. We multiply, so this becomes multiplication, and we take the reciprocal of the second fraction. So that's 2 over 7. Or, and this reference has, I've been using this reference to help people remember how to divide fractions since 1990. So yes, it's way out of date because nobody knows where it comes from. When division comes along, you must flip it. Which is reference to a Devo song. You must whip it. But nobody knows the band Devo.
I do.
You do? Okay. Or de-evolution. No, what's the source of? What happens if you give like 6 nerds musical instruments, you get the band Devo? So, multiply straight across. The negative times positive is negative. 5 times 2, we get 10. Over 3 times 7 is 21. 2 and 5 are not going to go into 3 and 7, so we get no common factor. That's final answer. And right here, can I reduce anything before we multiply? 5 doesn't reduce anything to 3. 5 and 7 can't reduce anything. There's no common factor. 2 and the 3 have nothing in common. 2 and the 7 have nothing in common. So I know if I check it before I multiply, we're not going to have any common factors. So just multiply 5 and 2, 10, 3 times 7, 21. And try to be honest with yourself. And if you don't want to raise your hand, I get it. But how many of you did the quiz without a calculator? 1. You get to use a calculator at any time for anything. Now, advice, whether you take it or not. If you have kids at home, if you have little brothers and sisters, take them the journey through math, and you know what it's like to struggle with math. First thing, don't go home and start complaining about math, because they'll latch on to that. Don't go home and say, well, I'm not very good at math. Nobody in our family has ever been good at math, because they're looking for the easy way out, just like everybody would. Nobody in the family is good at math. I guess I don't have to be good at math either. Okay, they will latch on to that. Second, never give a kid a calculator. Don't do it. Take the phone away, because there's a calculator on. Do not let a kid, at least until they're in geometry, when they're taking sines and cosines and tangents of angles, and they're using decimals for those values, they don't need a calculator. They have to know how to do these things by hand. Okay? The worst thing you can do is give them a calculator. Over here, subtraction, we need a common denominator. So for 5 and 7, what would the common denominator be? 35. That would be a 35. Don't forget, we're still subtracting. Okay. So I don't know if the answer is going to be positive or negative. I got a good idea by estimate. 3/5 is more than a half. 2/7 is less than a half. So more than a half minus less than a half is going to be positive. That's just thinking in my head. So I have an idea that it should be positive. So let's keep on going. To change this into a 35, we have to multiply by 7 over 7. 7 times 3 gives us 21. To change this into a 35, we have to multiply by 5 over 5. 2 times 5 gives us 10. And now it's just 21 minus 10 over 35. And it'll come backwards. Number 5, is it positive or negative? It's going to be a negative. We have a negative number, take away another negative number. So we're spending and we're spending again. So these two negative numbers are going to come and add up to another negative number. I have 78 negative 78.6, and then a negative 39.4. So how many negatives we have? 78.6, 39.4. So that adds up to 10. Carry the 1. 1 plus 8 is 9. 9 plus 9 is 18. We're going to carry 1. 1 plus 7 is 8. 8 plus 3 is 21. Right. 1 plus 8 is 1. So 118.0. So if you just put 118 or 118.0, unless the directions tell you to not put a decimal, either one of these should be fine. The answers I was giving, again, positive, so forgetting to leave the negative. And then again, right here, another division. First thing, what do you see? Is it a positive or negative answer? Positive. It's going to be a positive. You have a negative divided by a negative. So we know the answer should be a positive. So just thinking about positive. When division comes along, you're going to flip it. So this is a negative 20 over 3 times a negative 12 over 5. And when we multiply it, we multiply straight across. Now, two things you can do. You can go this way. This is 20 times 12. So 2 times 12 is 24. And then you have the 0, that 10, multiple of 10. This is 2 times 10 and then 12. So 2 times 12 is 24, and then times 10 is 240. So 20 times 12 is 240. Over 3 times 5 is 15. And on a few of the quizzes that I looked at different results, that was the common mistake. It wasn't reduced in lowest terms. And we know it's not in lowest terms because the numerator ends in a 0 and the denominator ends in a 5. So we know that there's at least a common factor of a 5. So it can be reduced. So this would be 5 times 45. No, 48, not that, 48. The denominator would be 5 times 3. And now you're looking at 48 over 3. 48 over 3 can be reduced. 3 goes into 48 16 times. This is equal to 16 times 3 over 3. The 3 is reduced. When 3 reduces completely, remember, 3 goes into 3, there's a 1 left behind. 3 goes into 3 one time. 16 times 1 over 1, and 16 over 1 is just 16. So the final answer is just 16. Okay, that's the really long way. You multiply together, and you get a big number, and then you got to try to see if it whittles down. We have 20 over 3, negative, times negative 12 over 5. If you reduce common factors before you actually multiply it out, your reducing will be done, and you won't have to worry about doing that. Now, I'm going to take 2 steps on it. The first step is, this is going to be a positive times a positive, so I'm going to get 20 times 12 all over 3 times 5. And the reason why I'm doing this is because I want to see if there's any common factor. So 20 is 4 times 5, which is good because there's a 5 down here. And 12 is equal to 3 times 4, which is good because we can do that. And I have a common factor of a 5 that I can reduce, and a 3 that can reduce. I'm left with 4 times 4, which is 16, and those are 1, so 16 over 1, which is 16. I reduced it before I actually multiplied the whole thing out. You have to sort that one? No. 20 over 3, nothing in common. But there's a 5 on multiplying. This only works with multiplication. There's nothing in common with that denominator, but this denominator, 5 goes into 5 once, 5 goes into that 20 4 times. 12 has nothing in common. Well, it's a 1 now. But 12 has something in common with that 3. 3 goes into 3 once, 3 goes into that 12 4 times. I'm left with a negative 4 times a negative 4 over 1 times 1. We get 16. We look for common factors before we multiply things out. Common factors are the only thing we can redo. Where we're headed in about a month is going to be something like this. You're going to have to factor that. this would be, I can't cross off anything, but you have to be able to factor this is x minus 4 times x plus 1, and this is x minus 6 times x plus 1, and there's my common factor. If we can't factor with numbers, we won't be able to get to the factoring with variables. You're not supposed to be able to do it on day one. But understand, we are building towards something. So if you ignore what we're doing today, or you think, oh, I got this, don't worry about it, and then you don't practice it, when we get to a month and a half from now, it's going to go, huh? Don't worry about going, huh, right now. Make sure you can do what we're doing right now. Don't take anything for granted. And if you're struggling with right now, you've got to ask questions. You've got to come to office hours. You've got to ask questions during class. You've got to go to free tutoring over the tutorial setting, the math setting. Okay, take advantage. All of this is stuff that we just got done doing, and it leads to 0.4. The only thing different is in 0.4, there's going to be variables attached to it. All right. If you're going to get it right, want to take the time. First thing, maybe read it out loud before you even do the problem. Hear it, and then, or at least if you're going to do the problem as you read it out loud as you do the problem, especially when you run into something like this. Simplify when you have consecutive signs. -12 minus a -6. Simplify the problem before you actually do the problem, if there's something you can do. I want to get rid of parentheses. I can't do anything with -6 because it's just -6, but I'm subtracting that. When you have two consecutive signs, if you have plus and then a negative, that's just minus. If you have minus and then you have positive, that's a minus. If you have plus, which we would never do this, plus a positive, well, that's just a single positive. But if you subtract a negative, when you subtract a negative, we're adding. So the bottom line is, if the signs are different, when you add a negative or subtract a positive, if the signs are different, it's a negative, a single negative. If you add a positive or subtract a negative, if the signs are the same, it's addition. I can still hear you guys over here. Hello. I can still hear, I'm going to have to I'm going to ask you one or two things. Instead of arguing each other or to leave, and you can come back on Monday. Because you're disrupting class. And you know why you're disrupting class? Because I'm taking time out of class right now to address it. you have obviously something to talk about. You're free to leave and go talk about it anywhere else on campus. Please. Please go talk about whatever you want to talk about outside. Or if you can't, you need to separate this. This is your education. This is their education. And if I can still hear you over here, and I'm still trying to focus on what I need to talk about, because my concern is everybody. Please. So last time I'm going to be nicer. So the signs consecutive are different. Minus. Consecutive sign is the same. Plus. So two consecutive signs that are different. This is now negative 12 plus 6 plus 8. Now, remember order of operations. I won't be off screen. Parentheses, we have exponents, multiply and or divide in order from left to right, add and or subtract in order from left to right. Well, this is just addition subtraction. So we're just going to go from left to right. 12 negatives and 6 positives. What do we get? We get 6 negatives. 12 negatives and 6 positives and 6 negatives, and then plus 8. 6 negatives and 8 positives. 2 positives. 2 positives. Take the time to do one extra step. Think about the strategy that you've used in math before. Think about the attitude you might have had with math before. I don't even want to do the math. I don't want to do the homework. I don't want to do anything. I'm in class, whatever. You actually can be done with your math homework if you just take the time to do the steps and make yourself get that pattern, get that precision down, the habit, then trying to just think about it from scratch every time. If you don't do the homework for 3 weeks until the night before the test, you won't know how to do it as it accumulates. It's like tomorrow's the big race. I think I'll go and try to run a mile today. We got to build up to it. So you should be doing that homework all along. So when I see this question, I'm looking for any consecutive sign where you have minus and then something else happens, or plus something else. I got nothing. They're all just addition, 4 plus 9, and then take over 17, minus 19, and then add 12. So we're just going to go from left to right. So 4 plus 9 is 13. And I get it. You can just do this in your head. I don't mind. This is minus 17. I'm going to write it out. Minus 19 and then plus 12. 13 minus 17 is negative 4. Minus 19 plus 12. A negative 4 and a negative 19 is a negative 23. And then a plus 12. 23 negatives and 12 positives is going to be positive or negative. Negative, and then we have 11 negatives left over. Now there is one other way you can attack this. All of your positives, you have a 4 positive, you have a 9 that's positive, and you have a 12 that's positive. Those are your positive numbers, and then you have a 17 that's negative, and you have a 19 that's negative. Yeah. That's using the commutative property where I can switch in order as long as I don't change up the sign. The 17 has to stay negative, and 19 has to stay negative. I can rearrange the terms. So these 4 plus 9 is 13, and 13 plus 12, that's 22 positives. Negative 17 and a negative 19, that is a 36 that are negatives. 25. That's 13 is close to 25. So positive 25, take away 36 is negative. That's right. What will these first two be? Positive or negative? Negative. So it'll be a negative. I spent $7.30 and then another $2.10. So that's 40 cents, and we're not carrying anything, and that's a none. So it's a negative 9.4. And then we have, I can do this. That's a positive 8.6 and a positive 2.4. And I'm going to have a positive 10 and 1, 9, and 2 is an 11. So positive 11.0. Who has more positives or negatives? So the answer is going to be positive. So it's just going to be that 11.0 take away the 9.4. So when you do something like this on paper, most important thing is that your place values line up. So the tenths have to line up from the tenths, the ones, and the ones. Because here we got a bar. To subtract 4 from 0, we got a bar from the ones. So when we bar from the ones, we now have 0 here. But over here, we now take 10 1 and turn it into 10 tenths. You take $1 and you change it into 10 dimes. 10 dimes, take away 4 dimes, leaves 60 cents. Include 6 dimes. We have 0 in the ones place, $0. So now we got to borrow from the tens place. We take that $10 and change it into 10 1. 10 ones take away 9 ones, leaves $1. So $11 minus $9.40 is $1.60. All right, come on back at 9:30 and we'll do the rest and then we'll throw in the variables.